Hello everyone. In this video, we will discuss about some additional built-in data types supported by SQL, the index creation, the terms schemas, catalogs, and environments. We already covered a number of built-in data types supported in SQL, such as integer, float, character, etc. Right? In addition to these basic data types, the SQL standard supports several data types relating to dates and times. Let us look into that. The data type date displays the calendar date containing a 4-digit year, month, and day of the month. The data type time displays the time of the day in hours, minutes, and seconds. The data type timestamp, it's a combination of date and time. So if you're giving the data type timestamp, it displays the date as well as the time. So it's a combination of date and time. SQL defines several functions to get the current date and time. The current date function returns the current date. The current underscore time, that function returns the current time with the time zone. And the local time returns the current local time without the time zone. The timestamps are returned by current timestamp and local timestamp. The current timestamp function displays the time and date with the time zone, whereas the local timestamp function displays the local date and time without time zone. SQL also provides a data type called interval, and it allows computations based on dates and times and on intervals. For example, if x and y are of type date, then x minus y is an interval whose value is the number of days from date x to date y. So to get that intervals, we can make use of the data type named as interval. Now let us discuss about yet another data type used for storing attributes of larger size, that is of the order of many kilobytes to even gigabytes. That is for storing a photograph or a high resolution medical image or even a video clip. SQL provides a data type named as CLOB for storing character data and BLOB for storing the images as well as video clips. Okay, this LOB stands for large object. CLOB stands for character large object. So to store the character data, large amount of character data, we can make use of this CLOB. And the images and the movies or the video clips are usually stored in binary format. And so BLOB can be used for storing the images and video clips. Now let us look into some example. The book review, it's a variable which can be used for storing a large amount of user reviews, okay, which is in the form of characters. So the data type need to be used here is CLOB, and that we have to specify the size also. We can have a maximum of 10 kilobytes to store the book, reviews in the variable book review. Similarly, to store an image of 10 megabytes, we can define it as pic blob of 10 megabytes. And for storing a video clip, we can give it as movie blob of 2 GB. Since video will be having a little bit larger size, we have to specify that one in terms of gigabytes. So we can specify large object types using the data type CLOB and BLOB. CLOB can be used for representing character data and BLOB can be used for storing the image as well as the video clips. Now let us discuss about default values. SQL allows a default value to be specified for an attribute. The keyword default can be used for that. In the given query, while creating a table, the attribute total credit, the default value of the attribute total credit is declared to be 0 using the keyword default. So as a result, when a tuple is inserted into this student relation, and if no value is provided for the attribute total credit, then its value will be set to 0. So while executing this insert query, insert into student ID, name, department name, values, we are giving only the ID, the name and the department name. We are not giving the value for the total credit. So if we are not providing that value, then its default value will be taken. So its default value is 0. So the for the ID 12789, the total credit value will be set to 0. Okay. Now let us discuss about index creation. The term index is very familiar to us, right? At the end of every textbook, we'll be having an index page which lists out the terms used in that textbook along with its page number, right? So when we are looking into that page number, we can get the details about that particular term, right? Similarly, here also we can create an index on an attribute of a relation. So this index is nothing but a data structure which allows the database system to find out those tuples in the relation that have a specified value for the attribute. And we can retrieve that attribute details more efficiently without scanning through, without reading through all the tuples of the relation. For example, if you are creating an index on an attribute ID of the relation student, the database system can find out the record with any specified value like 22201 or 44553 directly without reading through all the tuples of the student relation. Okay. We can create an index using the create index command. The syntax is create index, index name on table name followed by the attribute name. For example, create index student ID index on the table name here is student. The attribute name is ID. So student in bracket ID. So this statement creates an index named student ID underscore index on the attribute ID of the relation student. Now let us discuss about the user-defined types. User-defined data types are based on the system data types. It allows the creation of complex data types with nested record structures, arrays, and multisets. So these user-defined data types are defined by the users and are based on the existing system data types. Okay, fine. The SQL supports two types of user-defined data types, distinct type and structured data type. First, let us discuss about the distinct type with the help of an example. Suppose that we are having two attributes named instructor name and student name. These two attributes can be defined using the same data type. So when we look into the physical level, these two represents same because both the attributes are defined using the same data type. Okay. And when we view them in the conceptual level also, the domain of these two attributes might have same domain. That means both represents a set of person's name, right? So when we are viewing in the conceptual level as well as in the physical level, these two attributes seems to be same. But the attribute like instructor name and department name, though they are defined using the same data type, when we view them in the conceptual level, these attributes should have distinct domains. That means the name of the instructor should not, and the name of the department both should be distinct. Also, at a practical level, assigning an instructor name to a department name is probably a programming error. So to detect such assignments or comparisons, SQL provides the notion of distinct types. So how to create a user-defined data type? As we said, this user-defined data type is defined by a user and is based on a system data type. Okay, so to create a user-defined data type, we need to specify the name of the new data type, the system data type upon which this new data type is based on, and nullability, whether the data type allows null values or not. Okay. The create type clause can be used for defining this user defined data types. The syntax is create type the new data type name as the system data type. Okay. An example, create type dollars as numeric 12,2. So it defines a user defined type named as dollars of decimal numbers with a total of 12 digits, two of which are placed after the decimal point. Okay, so the dollar is a user defined type with a total of 12 digits. It is a decimal number with a total of 12 digits. Okay, and we can make use of this user defined data type to while creating a table. In the example, create table department, the department name, varchar of 20, building, varchar of 15, the budget, the attribute budget, its type is dollars. That means it is a numeric value. It is a numeric value with a total of 12 digits and two of which are placed after the decimal point. So instead of specifying it as numeric 12,2, we are giving it as dollars. That is the new user defined name for representing this system data type numeric 12,2. The second type of user defined data type is structured data type, and this data type are used for defining composite attributes of an ER design. Okay, as we know, composite attributes are nothing but a set of attributes. Okay. To define the structured type to represent a composite attribute name with component attributes first name and last name, the command can be given as create type name as first name varchar of 20, last name varchar of 20. So similarly, we can define another composite attribute address with three component attributes street, city and zip code. Using these two composite attribute name and address, we can create a table person. Okay, so in the create command, create table person, the p name, the data type of p name is given as name, which is a structured data type which consists of two component attributes first name and last name. And the second attribute p address, its data type is the newly created structured data type address, which consists of three component attributes street, city and zip code. And the third attribute is date of birth with the data type as date. Okay, so instead of specifying the street, city and zip code, we can give the structured data type address. So the address and name are the new user defined data types. Okay. Now let us discuss about the terms schemas, catalogs and environments. The database systems provide a three-level hierarchy for naming the relations to avoid the naming clashes. That is to ensure that the users uses unique names for different relations. So in this three-level hierarchy, the top level of the hierarchy consists of catalogs, also called as databases, and each of this catalog contains schemas. SQL objects such as relations and views are contained within these schemas. Okay, so the three levels are at the top level, the catalog, also called as databases, then the schemas and the SQL objects. Okay. To perform any action on a database, a user or a program must first connect to the database. And this user should be an authorized user. That is, the user must provide the username and password for verifying the identity of the user. When a user connects to a database system, a default catalog and schema will be set up for the connections, and this combination is unique to each user. So to identify a relation uniquely, a three-part name may be used. The catalog name, the schema name, and the SQL object name, that is the relation name. So catalog file dot university schema dot course. The dot operator can be used for separating these three parts. Okay. The catalog part of the name can be omitted if the user is using the default catalog. And if a relation is in the default schema for a particular user, then even the schema name can also be omitted. So, if the catalog and the schema is the user's default catalog and schema, then that name can be omitted. If a user wishes to access a relation that exists in different schema than the default schema for that user, then the name of the schema must be specified. With multiple catalogs and schemas available, different applications and different users can work independently without worrying much about the name clashes. We can create and drop the schemas by means of create schema and drop schema statements. In most database systems, the schemas are created automatically when user accounts are created with the schema name set to the user account name. The default catalog and schema are part of an SQL environment that is set up for each connection. And this environment additionally contains the user identifier, which can also be called as authorization identifier. So, in this video, we discussed about some additional built-in data types supported by the SQL, the index creation, and the terms schema, catalog, and environment. Thank you.